Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher Bronwyn Slate. If you'd like to join me live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our 9th and final week of our course. At this point, you definitely should be submitting work for marking. A reminder that the support questions, the ones with the little pencil icon, are not for marking. These are practice problems. You decide which ones and how many to do. If you are understanding a concept, it is okay to skip questions. You don't have to do them all just because they're there. The answers are in the back of your booklet, so I strongly encourage you to do some questions and then check your work to make sure I'm on the right track, though, just so that you're not assuming you're understanding it and making big mistakes. The key questions are the marked questions, and they are with the little key icon. These ones, you need to do all of them. You need to show all of your work, your steps, and your thinking, because then I understand what it is that you understand. And if you're struggling with something, it gives me more information so that I can support you. So you submit your work in one of three methods. The first is to scan it and send it your work in electronically. If you have a device, you could use that device to scan. Apple devices have Notes apps that scans, and Android devices has a Google Drive app that scans. These are free apps that are fairly straightforward to use. However, if you need some support to figure it out, on my YouTube channel, there are tech tutorials that walk you through step-by-step how to use them. So you can go and check that out and hopefully figure out how to make your files smaller and a little bit easier to send. Once you have it as a file, you can send it to me either through email to studentwork@nnec.on.ca and CC it to me directly at bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger, where my name is B-Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. You can just stick your work in there at any time, and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also send their work in by fax. Just give us a heads up that it's coming, because sometimes things get lost in the shuffle. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B-Slate Wahsa. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after broadcasting in a playlist called MBF3C. So everything is there, so you can access them whenever it is most convenient for yourself. There also are short videos on that channel that explain common errors and confusing concepts. So things that you might be struggling with that are a little bit outside of the concept of our course, but you might need some help. So check that out there instead of just doing a general internet search first. Math is a really visual subject, so I strongly encourage you to access the videos. This is going to give you the most information and really set you up for success. Either watching me through Zoom, you don't have to talk to me, just watching is fine, or watching the YouTube channel when it's convenient for you. These are great options. If neither of those work for you, let me know, and I'm happy to send you a copy of the recordings so that you still have the full experience. If you have any questions or concerns, please reach out and connect with me. You can email me at bronwyn.slate@nnec.on.ca. You can connect with me through Facebook at B-Slate Wahsa. Call me at 807-737-1488, extension 2209. Or toll-free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that is not a good time to try to get a hold of me. Today, we will be looking at Unit 3. In previous sessions, we've reviewed Unit 1, which was lessons 1 through 5, and Unit 2, which was lessons 6 through 10. Today, Unit 3, we will be reviewing lessons 11 through 15. But first, let's activate our brains with some mental math. I don't believe in mad math minutes. They cause stress and anxiety, and generally, in my experience, don't help. Instead, I like to develop strategies that we can use in various situations that get our brains to work and manipulate numbers. Today's question is 13 times 56, and we're using the strategy of making a landmark. So making a landmark, you can do it in a couple of different ways. For me, this to me looks like, well, 13 times 56 is really close to a friendly number. For me is 13 times 50. So 13 times 50 is, 50 times 10 is 500. 50 times 3 is 150. So that's going to be that's going to be 650. And then plus, we're going to do 13 times 6. So 13 times 6 is, 10 times 6 is 60. And 3 times 6 is 18. So that's going to be 78. So then in total, that is going to be 728. So sometimes using a number that is close by, that is friendly, is a good way to do some multiplication. I want to go over what the final assessment is going to look like so that you're prepared, so that you know that this is something that takes a bit of time. The final assessment is not an exam, but a culminating assignment. So again, this isn't something that you can just leave to the last minute and do on the last day before everything is due, because it's going to take you some time. It still covers all of the 20 lessons, so you still need to complete everything first. And it is open book. So you have access to your assignments with my marked comments. You have the YouTube videos, so you can go back and review things as you're going. You have the IL booklets. You can refer to all the lessons there. You can use Desmos, the virtual manipulatives that you've used in class, everything. You can talk to people. It's totally fine to use all the resources that you have access to. As I said, it's not timed. You don't have it for just one day, for 2 hours or something like that, like an exam, but you will have a deadline. So I would say probably 2 to 3 weeks is what you're going to need to do this, because it is not a small project. It's a large project. But we can talk about it within your life, what makes the most sense for you. The structure is unfamiliar, most likely. It is not the same as here's a bunch of questions and answer them all. You have to be a bit creative, and you're really showing me what it is that you understand. Again, it is time consuming. It is not something that you can do really quickly. So I strongly encourage you to get all of your lessons in so that you can make sure you have enough time before the middle of June to get your culminating assignment completed. So I would say probably getting all your assignments in by the end of May so that you have time to do your culminating is your best bet, if not sooner. Totally sooner is fine. So let's look at our review topics today. So lesson 11 was trigonometry ratios. So this is your sine, cosine, and tangent, your primary ratios. Remember that you have to label your right angle triangle in order to understand the relationship, because that's what we're comparing. Also, you have to have a right angle triangle. You can memorize it as SOHCAHTOA, is something that is useful for some folks. Personally, was not useful for me because spelling was never something that was helpful for me, just confused me. So I just memorized them straight as sine A equals opposite over hypotenuse. That's what the definition is. Cos A is the ratio between the adjacent side to the hypotenuse side, and tangent A is equal to the opposite side to the adjacent side. Remember, A is your reference angle. You can solve for both an unknown side or an unknown angle. You have to use the inverse function when you're doing that. Remember, your calculator must always be in degrees when we're doing trigonometry. Most of the time, your calculator is in degrees, but if a button gets pressed accidentally, you might not be in degrees, and then you'll get answers that make no sense at all when you do trigonometry. It won't affect when you're adding and subtracting or multiplying, but when you're doing trigonometry, it will have a big impact. So make sure your calculator's in degrees. When you are solving for an unknown angle, you remember you need to divide your ratios. I strongly encourage you to round to at least 4 decimal places if you are writing it down. And then you have to use that second function on your calculator for sine, cosine, and tan to get your sine inverse, or your sine -1, as you might call it, or cos -1, or tan -1. So how you decide which ratio to use is based on the information that's in the question. So here we have an example of a triangle BCD. Angle B is 36 degrees, side B is 48, and side C is N. So first up, we need to confirm that it's a right angle triangle. Yes, it is. There's a right angle at angle D. Then we need to label our sides of our triangle. So based off of our reference angle, which is angle B, that's the angle that we know something about. You can see that side B is the opposite, side C is the adjacent, and side D is the hypotenuse. Then we need to identify which information we're solving for and what we know. So here we know we're looking for side N, which is the adjacent. We know the opposite side and we know the reference angle. So using that information, we can then choose our ratio. So we can think about, we have sine B is opposite over hypotenuse, cos of B is adjacent over hypotenuse, and tangent of B is opposite over adjacent. So because we know our opposite side and we are looking for our adjacent side, have a reference angle, we're going to be using tangent B equals opposite over adjacent to solve for side N. You get fairly comfortable with, but you need to practice this. All right, so let's do some practice questions. Number 1, solve for the unknown side or angle. We have a bunch of different triangles. So part A, we have a triangle. I haven't labeled the corners, the vertices, that's fine. But we have angle, well, we have side X, so we'll call this angle X is 62 degrees. We have a right angle triangle, great. So my reference angle is X, 62 degrees. So side X is the opposite. And side 34 is the hypotenuse. You can still label the adjacent if that is useful for you. You do not have to. Labeling just the sides that you know or have a variable for is fine. Then here, because I have opposite and hypotenuse, I know that that is sine. So sine X is equal to little x over 34. You can write it all out first because I don't have a ton of space. I'm not. So then in order to isolate for little x, we have 34 times sine x is equal. Oh, except we know what sine x is. My bad. We know that information. This is why writing it all out is good. Sine x equals opposite over hypotenuse. And then I can fill in what I know. So sine x is sine 62 is equal to x over 34. And then 34 times sine 62 is equal to x. So x is equal to, again, you're going to use a scientific calculator. That is not what I wanted. In order to have your sine on there, if you don't have a scientific calculator, if you don't have a calculator that says sine, you need to use Desmos or find one. So this is saying that side x is equal to 30. And that's what we do. Part B, we have reference angle B, which is unknown. Then across from B is our opposite side, which is 43. The side B is our adjacent side. We have a right angle triangle. So opposite over adjacent is tangent. So tan B is equal to opposite over adjacent. You can look up your sine, cosine, and tan ratios. You don't have to have them memorized. I do because I've been doing this for a long time. So tan B is equal to 43 divided by 36. So tan B is equal to, we're going to do 43 divided by 36. Now you can leave that decimal in your calculator, 1.1944, or you can just round it down to 4 decimal places. Either way, it's fine. Now, because we are looking for the angle, we need to do tan inverse of tan B in order to cancel those out. Find our angle. We do it to one side. We have to do it to the other side. So angle B is equal to, remember on Desmos, you go to function, and then you go tan inverse, and then you can put your numbers in, either using the full digits or just the rounded digit, and we get an angle of 50 degrees. Remember here on Desmos, you can see where it says degree. If you change that, it says radians, and that changes our answer significantly. So that's why it's important to keep it in degrees. Part C, we have a triangle with a reference angle of 14 degrees. Then we have adjacent and a hypotenuse. Let's call this reference angle C. So adjacent and hypotenuse is cosine. So cos of C is equal to adjacent over hypotenuse. Cos of 14 is equal to 13 divided by T. Then to isolate for T, I'm going to multiply both sides by T and then divide both sides by cos 14. So T is equal to 13 divided by cos 14, which is equal to 13.4. So T is equal to 13.4. And that's how we solve triangles using primary trigonometry. Okay, so lesson 12 was law of sines. It's really helpful if you understand the steps that we just went through first from lesson 11 before moving on to the rest of this unit. Again, sine law, this entire unit, I mean, generally your calculator has to be in degrees, but this unit, lessons 11 through 15, if your calculator is not in degrees, it's going to have a big impact. So make sure your calculator is in degrees. So with the sine law, you need to remember that we label our triangles with vertices have capital letters, sides have lowercase letters, and the opposites have matching letters. So the side opposite the vertex D, the corner D, is side D. Side opposite corner E, the vertex E, is side E. Side opposite F is F. Capital F on the corners, small f on the sides. So we use the sine law when we do not have to have a right angle triangle. We can have any kind of triangle. And we use this when we know two of our angles and a side, or when we know two sides and an angle, as long as the angle is opposite one of the known sides. Then we have two formulas that we can use. Remember, they're the same formula. They're just one, you do have to do less algebra for sides when you do less algebra for angles, but they both work in all situations. So if you just want to use one all the time and then do the algebra, totally fine. If you're solving for angles, then I encourage you to write sine A, so the capital A, which is your angle, divided by A equals sine capital B divided by little b equals sine capital C divided by little c. So your capital letters, your angles are on the top, so it's going to have to do less algebra. If you're solving for a side, then we flip them and we have our small letters on the top because we're solving for a side, and that makes us have to do less algebra. So little a divided by sine A equals little b divided by sine B equals little c divided by sine C. These are the same, but make our lives a little bit easier if you want. All right, practice question number 2. Let's solve for the unknown side. We have a triangle that is not a right angle triangle, so we're going to see if we can use the sine law. We have we have 2 angles, and we know the sides across from those angles. So 2 angles and a side means that we can find the other unknown side. So we're going to say we're solving for a side. So I'm going to put x over sine x is equal to y over sine y. Remember, we only need 2 of these ratios. We could use any of the 3 depending on the information that we have. So x over sine x, angle x is 95 degrees, is equal to, sorry, too many equal signs in this line, is equal to y, which is 15 divided by sine 38. Then to isolate for x, we're going to multiply both sides by sine 95. So 15 times sine 95 divided by sine 38. So x is equal to 15 times sine 95 times, not times, divided by sine 38 is equal to 24.3. We'll just say 24 because we have whole numbers. So side x is 24. And that's how we use the sine law to solve for an unknown side. For number 3, solve for an unknown angle. We have a triangle ABC. Remember, this symbol here is beta, which is a Greek letter, which is what we use sometimes as unknown angles in geometry. So we have 2 known sides and 1 known angle, and they're across from each other again. So that means that we could use the sine law. We had to have those relationships. So here we're solving for an angle. So I'm going to say sine beta over B is equal to sine C over C. And then I'm going to fill them in. So sine beta over 28 is equal to sine 86 over 54. Because isolate for sine beta, we're going to multiply both sides by 28. Now here, we're going to do our division. 28 times sine 86 divided by 54 is equal to 0.5173. Then remember we have sine beta, so that means that we need to do the inverse. So the inverse of sine beta is equal to the inverse of sine of 0.5173. So angle beta is equal to, so we have to get the inverse of sine of our number. We get 31 degrees. That is how we solve for unknown angle using the sine law. Lesson 13 is looking at the law of cosines. So again, calculator in degrees, gotta keep reminding you. For the cosine law, we need to know 2 sides and a contained angle. So here in this picture, we have triangle TVU, And we can see that angle V is what we know, and we know side U, and we know side T. So that means we can solve for side V. We have to have this contained angle in order to use the cosine law. Or the other option is that we know all three sides. Then we can find any of the angles. Also, we have two formulas, which is just the algebra has been done before. Again, you could use both versions in any situation. Just one is going to be easier to solve for sides and one is going to be easier to solve for angles. But you could just use one and then do the algebra. That is totally fine. If you're solving for a side, doing c squared equals a squared plus b squared minus 2ab times cos c. If you're solving for angles, we say that it's cos c equals a squared plus b squared minus c squared divided by 2ab. Again, it's just about the algebra. You don't have to do one or the other. So for the practice questions number 4, we're solving for the unknown side. We have triangle QRS. We see that angle R is 56 degrees. Side S is 48. Side Q is 39. And we're looking for side R. So because we have the contained angle, we can use the cosine law. Because we're finding for a side, we're going to do R squared equals S squared plus Q squared minus 2SQ times cos R. Again, you don't have to have this memorized. You can, if you want to change your sides to A, B, and C so that it matches what our formula is, that is fine. Then we're just going to fill in what we know. So S squared is 48 squared plus Q squared is 39 squared minus 2 times 48 times 39 times cos of 56 degrees. So R squared is equal to, let's do that on the calculator. Again, this is why you need to have a scientific calculator, because there is lots of things that we need to do on the calculator we don't want to do mentally. Times cos 56. So we get 1,731.38. Then we have, that's the square root. So we have to take the square root of both of those things to get R. So we get 41.6. So side R is equal to 41.6. That's how we solve for an unknown side. Solving for an unknown angle. So we have triangle MNP with 3 sides. N is 24, P is 61, M is 46, and we're looking for angle M, which we've indicated with alpha, which is another Greek letter. So for solving for an angle, we can use the angle version, which is cos M is equal to, this one I don't have memorized as well, but I believe it is P squared plus N squared minus M squared all over 2P N. Basically, M is our unknown, so either unknown angle or unknown side, and the other 2 letters are interchangeable, so it doesn't matter which order they go in. So cos of alpha is equal to 61 squared plus 24 squared minus 46 squared, all divided by 2 times 61 times 24. Again, you don't have to have these memorized, right? Even for your culminating, you can look them up. Sorry about that. Okay, so put this in our calculator. 61 squared plus 24 squared is to 4. No, minus 46 squared. Put that all in brackets so that I can divide it all by 2 times 61 times 24. Again, we're going to write this in, if we're writing it down, we are writing it to 4 decimal places at least. So 0.47788. And then we have to do cos inverse of cos alpha. As you can see, my alphas are changed, sort of what they look like. It's all good. Cos equals to cos inverse of 0.74488. So angle alpha is equal to 41.9, so 42 degrees. And that's how we solve for an angle using the cosine law. Lesson 14, we started to do trigonometry and problem solving. So these are the applications of those 3 types of trigonometry that we've been using. So first thing we need to do is we need to identify which trigonometry strategy to use. Are we using primary trigonometry, SOHCAHTOA, because we have a right angle? Are we using the sine law because we know 2 angles and 1 side, or 2 sides and 1 angle that is opposite a known side? Or are we using the cosine law because we know 2 sides and 1 contained angle, or 3 sides? As you can see, all triangles with this some of this information, any of these 5 information, you're going to be able to solve. They cover all of our possibilities as long as we have this information. If we're missing, if we don't have those 3 pieces of information, then we don't have enough information. So that's the only other possibility. We talked about the angle of elevation, which is when you are looking straight out with your eyes and then up to an object, or the angle of depression, which is when you're looking straight out to the horizon and then down to an object. So remember, we look with our eyes and not with our feet. So this is part of when you're doing problem solving, you need to keep that in mind. Number 6 of our practice questions, the angle of elevation to the top of a mountain is 45 degrees. If I walk 100 meters further away, the angle of elevation is 44 degrees. What is the height of the mountain to 1 decimal place? So I strongly encourage you to draw yourself a picture. So as we know, it does not need to be beautiful. We have a person, the angle of elevation. So we're looking from straight out and up to the top of the mountain is 45 degrees. Then our person walks 100 meters and looks up again to the top of the mountain, and this angle of elevation, sorry, my person got shorter. My person should not have gotten shorter. Okay, so then looking up from there, that angle is now 44 degrees. There are tools so you can actually measure this. What is the height here of the mountain is what we're looking for. The height is perpendicular to the ground. So this is a 2-part question because we want to know this perpendicular height, but we don't know anything. We don't know enough information. We don't know that it's halfway between that height. Our triangle could be kind of like that. And so then our height is over here between our 100 meters and that. So we can't assume that it's 1550. So we need to do first, we need to find this angle because we have so to find that angle, we know that a triangle is 180 degrees. Take away 45, take away 44. Well, 45 and 44 is going to be, well, 45 and 45 is 90. So it's going to be 89. but 190 is a half of 180. So that means that we're left with 91. So this angle is 91. So now we could use the sine law to find out one of the extra sides. Call this x. Let's do it in green. And then from there, we can figure out what the height is. So first, we're going to solve for x. So x over sine 44 is equal to 100 over sine 91. So x is equal to 100 times sine 44 divided by sine 91, which is equal to, now I'm going fast because this is review. So if this is all super confusing for you, then you need to go back to this unit and check out these lessons. I feel a little guilty that I'm going fast, but again, review. So that means that that side is 69.5. So now we can put this down here for a second. We can see that this is 69.5. So now we can use this as our reference angle and see that this is our opposite and our hypotenuse. So we have our second step is sine of 45 is equal to h over 69.5. So h is equal to 69.5 times sine 45. Times sine 45, which is equal to 49 meters. So the mountain is 49 meters tall. Often with these questions, there is multiple steps that you need to do. You don't have all the information and you need to do multiple steps. I was supposed to do it to one decimal place, so I think that it was 48.6 or something. My bad. Read the question. Follow the instructions. All right, number 7. A park is enclosed by three paths, so it makes a triangular shape. If the path lengths are 145 meters, 230 meters, and 190 meters, what is the area of the park? Again, strongly encourage you to draw a picture. So it doesn't matter if our angles are perfect or our lengths are to scale. I don't care. I just want you to have, drawing a picture just helps you visualize it. 190 is 190 is not my shortest side. I thought it was 90 per second. So just doing it so that you have roughly the shortest one on the shortest side, just so that your brain doesn't implode. It's a good idea, but that's all that you really need to know. So I have a park. I'm going to label my vertices. Again, you can label them whatever you want. So that means that this is side B, this is side A, this is side C. Again, I'm looking for in order to find the area of a triangle, I need the height times the base, right? So again, I need to find an angle. If I find angle A, then I can figure out what my height is, and then I can figure out what my area is. So first I need to find angle A. Now, because I have three sides, I can use the cosine law. So cos of A is equal to c squared plus b squared minus a squared divided by 2cb. So cos of A is equal to 190 squared plus 230 squared minus 145 squared divided by 2 times 190 times 230. So using our calculator to do that. Sorry, I seem to have an absolute value and I don't know why. Minus 145 squared, all of that divided by 2 times 190 times 230 is equal to 0.7777. So then I have to do the inverse of cos A is equal to the inverse of inverse of 0.7777 defined by angle A. So I get 38.9, so 39 degrees. So angle A is 39 degrees. So now I can look and say, okay, well, my opposite is my height, is my H. My hypotenuse is 190. So I'm going to use sine of A equals opposite. Sorry, I have write this up here because it's going to be small. So sine of A, which is 39 degrees, is equal to H over 190 degrees. So H is 190 degrees times sine 39, which is 120 meters. So H is 120 meters. So that means my area of a triangle is base times height divided by 2. So my base is 230 because I drew my height perpendicular to that line, times my height, which is 120, which I figured out, divided by 2. So 230 times 120 divided by 2 is equal to 13,800 meters squared. And that is your area of the park. So again, multiple steps. It's really important. This is why drawing your picture helps. It's a little bit messy. Keeping yourself organized is all a good plan. So then our final lesson is lesson 15, which is creating nets. So we were looking at nets, which is a flat version of a 3D object that can be folded to create that 3D object. Patterns are flat versions of a 3D object where the parts are separated, so they cannot be folded, they need to be reattached. And plans are a flat version of a 3D object that shows the front, the side, and the top views, so it can be reconstructed, but they're just a plan. You can't refold it or reattach these pieces in order to make our 3D object. So here for part 8, which of these following nets can be folded into a cube? So a cube is a 6-sided square figure. So the best way for me that I think about doing this, because it can be really hard to visualize these, is by using our the Polypad virtual manipulatives. So here we want to use the here, if I have a cube, I take a cube out and then I can unfold it. And I can move it around. So then if I move my pieces around to make one of the images, so I made image A, color doesn't matter, and then I can fold the net and I can see, did that turn into a cube? Nope, it did not, because this part sticks out. That did not work. So then I can unfold it again. So B does not turn into a cube. And I can make my next shape. So A did not make a cube, B we're now going to make. I highlight them and I fold the net. And I look and I see, oh, if I turn it around, that can fold, that can make a net. So B is a net for a cube. Then I can make part C. It's actually like that. I rotate it around. So then I fold that net, and we can see that does not fold into a cube. C does not work to be a cube. D, so this is a really useful tool because these can be really, really hard to visualize. That one that looks like a little dinosaur. Oh, that one does fold into a net. So far B and D are nets. The other ones are not. Remember, you can get this as an app as well on your, if you have a device. E does not fold into a net. Again, we've got this hole. And finally, F. F folds into a cube. So B, D, and F all fold into cubes. Using that tool is super, super helpful because otherwise it's super hard to visualize. And that is our review for Unit 3. Lesson 5 is 15 is sort of a short, small one. The other ones are more intense. So definitely spend time on those other ones to review. If you have any questions, please reach out and connect with me. Give me a call at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca, or connect with me through Facebook at bslate Wahsa. Remember, all of our lessons are up on my YouTube channel, which is also called bslate Wahsa, under a playlist MBF3C. Everything is there so that you can find it. So please go back and review those things. The trigonometry stuff can be really tricky. It's a lot of trigonometry, it's a lot of algebra, it's a lot of organizing. So go back and review, slow things down, pause things, try questions out, see if you match me, ask me questions is your best strategy. And good luck with your review. Thanks so much for joining me today. Which